hello student, welcome to VAVA classes. Today we start the chapter that is unit and measurements. So first, before starting, that's introduction of unit and measurement. So what are the introduction? Means you see, let us explore some of the questions. First, why does the rainbow have specific colors in a specific pattern? Second, why do stars twinkle? Third, what is a metroid? So these are the metroids, you see. So what are the metroids? Why do day and night occur in a cyclic order? So day, night, it is occurring in cyclic order. All these questions lead towards curiosity. So then this curiosity leads us towards, that is science. This curiosity leads us towards science. So what is science? Science is the systematic gain in knowledge by knowing the process of learning, that is the physical or material world gained through observation and experiment. Means we observe it, also experimentally ame taku verify kari paruthiba, then it is called science. Anything we observe and experimentally it is verified. This is called science. So first, observation. So this is observations, and second is experimentation. So when we observe a railway track, it will appear that gradually it is narrowing, but actually it is not so, because the tracks are all parallel. So observation need not be always correct. Can't trust just on observation, then experimentation is essential. For observations, we require for precise calculations. Example, in Ohm's law, we can say the ratio of voltage to current may be constant, may not be constant. We need to measure things for accurate results. So the purpose of experiment is to establish the laws, hence measurement of different physical quantities is extremely important. This leads us to a very important topic, that is measurement. So units and measurements, let us understand some terms before we start this topic, that is weight, height, length, time, temperature, pressure, volume, velocity, acceleration, force. What are these quantities called in physics? These quantities are called physical quantities. These are called physical quantities. So what are the physical quantities? The quantity that can be measured directly or indirectly is called a physical quantity. So examples of physical quantities are length, mass, velocity, temperature, area, volume, density, force, etc. All are measurable quantities. We can measure them directly or indirectly. Non-physical quantities. A quantity that cannot be measured is called as non-physical quantity, like love, heater, like, etc. So which of the following is not a physical quantity? Length, mass, time, air. So it is air. Which of these is a physical quantity? Acceleration, like, dislike, heater. That is, acceleration is a physical quantity. Curiosity leads us to science, only observations, only experiment, none of these. It is science. तापर आमे देखिए बर्तमान फिजिकल क्वांटिटीज. सो फिजिकल क्वांटिटीज which can be measured directly or indirectly or in terms of which any law of physics can be expressed is called physical quantities. There are two types of physical quantities in SI system, that is fundamental quantity and derived quantity. Fundamental quantity and derived quantities. बर्तमान देखा व्हाट इज फंडामेंटल क्वांटिटी. So a physical quantity which does not depend on any other physical quantity for its measurement is called a fundamental quantity. So examples of fundamental quantities, that is mass, length, the unit is meter m, mass kilogram, that is kg, time, temperature Kelvin, amount of substance mole, luminous intensity and electric current ampere. A luminous intensity, it is a measure of intensity of brightness of light. So brightness of light measure, this is luminous intensity. So unit is candela and CD. So these are the 7 fundamental quantities. Then except this fundamental quantity, there are a supplementary 2 supplementary quantities. So these are, that is plane angle, that is radian, and solid angle steradian. So this is the plane angle we are measuring, this is theta, this is measured in radian, and this is the solid angle, that is angle made by a cone at an apex, that is solid angle. So it is the measured in steradian. So it is the 3-dimensional angle, it is the 2-dimensional angle, or an angle inscribed by surface at a point is called solid angle. So here, that is, this is the, we told this is surface. So this is the surface, this surface made this angle here, it is called solid angle. So this is the solid angle. So these are the fundamental quantities. Now we see derived quantity. So what are the derived quantity? The physical quantity which can be derived from more than one fundamental quantity is called derived quantities. So fundamental quantity, by using fundamental quantity, we can derive the physical quantity. That physical quantities are called derived quantity. Example कौन ना, area, density, force. Area, so area is equal to length into length, means here fundamental quantity आम use करूँ length. Density, density is mass by volume. So mass is a fundamental quantity. So volume is length or cube, length into breadth into height, all are length unit. So here we use mass and length as fundamental unit. In this way, by using these fundamental units, we derived these quantities. That is why these quantities are called derived quantities. So area, density, force, acceleration, work, etc. Then you see, so velocity meter per second, so means displacement by time, L by T, length by time. Acceleration meter per second square, that is velocity by time by length by time रो square. Work kg meter square per second square or joule. So it will be mass, length and time. So all these are the derived quantities. So बर्तमान देखिबा केतरा MCQ questions. A quantity that can be measured is called a physical quantity. The physical quantities which are expressed in terms of more than one fundamental quantities are called derived physical quantity, fundamental physical quantity and supplementary quantity. That is derived physical quantities. There are these fundamental quantities. There are 7 fundamental quantities. Acceleration is a derived physical quantity which depends on these fundamental quantities, that is 2, because it depends on length and time, because acceleration is equal to length by time रो square. So next, charge is a dash quantity. So charge is a fundamental quantity, derived quantity, non-physical and supplementary quantity. That is, charge is a derived quantity. So we can write charge is equal to current into time. So, current is a fundamental quantity, time is a fundamental quantity. So, charge is a derived quantity. तापर देखिए यूनिट. So, to measure every physical quantity, it should be compared with a standard. सब physical quantity को measurement करिया पई ता गोटे standard सहित compare करा जाए. That standard is called unit. That is measurable quantity is physical quantity. That is mass, length, time, area, force, these are the measurable quantity. So, a physical quantity can be measured in terms of its magnitude and unit. For example, so distance is equal to 25 kilometer. So, here 25 is the magnitude, means the distance is equal to 25 times magnification of 1 kilometer. So, if this is 1 kilometer, then it will be, when 1 kilometer get added up to 25, then it will be 25 kilometers. So, this is magnitude and kilometer is the unit. So, unit is standard reference which is used for measurement of a physical quantity. So, unit is a standard reference which is used for measurement of a physical quantity. So, unit, so measurement of any quantity involves comparison with a certain basic arbitrary chosen internationally accepted reference standard called unit. The units for the fundamental quantities are called fundamental unit and the units of derived quantities are called derived quantities. So, in some wrong ways units were considered where physical quantities used to be measured. Length was measured with the help of a hand, but all hands are slightly different or there are different sizes. So, the unit should be have certain characteristics, that is 1 league is equal to distance covered in 1 hour by walking. So, button देखिबा there are some characteristics of a unit. Suppose we have weight measures of only 100 and 200 grams, but I want to measure the weight of my elephant. So, this person is telling I might measure 100 and 200 gram, but this person is telling I measure the weight of my elephant. So, that means the unit must be a suitable size and easily available. So, size of it should be a suitable size and easily available. A unit should be easily available and reproducible at any place required. The unit must be universally accepted. At least a physical unit must be invariable and well defined. That means yesterday a kilogram was 1000 gram, but today is only 800 grams. How? So, next 5, it should not be perissageable. Now, button देखिबा relation between magnitude and unit of a physical quantity. So, the numerical value obtained on measuring a physical quantity is inversely proportional to its unit. So, n is inversely proportional to unit. That implies n1 u1 is equal to n2 u2. Suppose I take n1 and n2 are the numerical values and u1 u2 are unit. For example, 1 kilogram. Here 1 is the numerical value, kilogram is the unit. It will be 1000 gram. So, 1000 gram means 1000 is the quantity or numerical value and unit is gram. So, kilogram to gram it is decreasing. So, numerical value 1 to 1000 it is increasing. MCQ question. This is a standard used for the measurement of a physical quantity, that is unit. Then system of unit. So, there are various of a system of units. So, these are first is FPS system. FPS system, F for foot, P for pound and S for second. This system is called also British system. कहीं ना ब्रिटिश आमर लंडन रे आमर दिस सिस्टम ब्रॉडली यूज होथला तो सेति पई इट इज FPS CGS system CGS C stands for centimeter, G stands for gram and S stands for second. This system is also called French system. Similarly, MKS system. So, MKS means meter, kilogram, second, and ultimately it is also called metric system. So, first here now CGS system, MK system, meter, length, kilogram, mass, second, time. FPS system, foot, pound and second. Foot is length, pound is mass and second is time. Then once that is the scientists in of all world meet internationally. So, because of different system of units, so they finally come to a conclusion by a general conference of on weights and measurement in 1971 for international use in scientific, technical, industrial and commercial work at France. They introduced an international system of units called System of International Units or SI unit. System International D units. So, that is SI unit. So, which of the following is a characteristic of a unit? The unit must be universally accepted, it must be invariable and well defined, it must be of suitable size and easily available, all of the above. So, result is all of the above. A standard unit is a necessary for the sake of accuracy, convenience, uniformity, all of the above. A standard unit is necessary for the sake of accuracy, convenience, uniformity and equal justice to all. Thank you.